So today we are going to discuss further with the motions, and my goal is at the end of this video, and this review, at the end, actually I want to talk about the projectile motions. I hope tomorrow I will finish this fast. What is the projectile motions? That's right. One correct word, like here. Gary, be careful, watch out. I will throw something to you.
I cannot see it. That's really smart.
Small, you know. That's called projectile motion. A cannon throws the ball. Okay. Netherlands, England. The Greek, the war between them, right? You still remember they used cannonball as they are fighting each other on the sea.
I was there.
You were there. Wow, good. So as the England fought against the Netherlands and become the empire of the oceans, you were there.
Yeah. I was there for all of it.
The Swiss were always there, they just never did it.
Stop. That's because they're neutral, okay?
But we start from here first. We try to understand. Thank you. Thank you for your confirmation that you understand. The first one is called displacement time graph. The second one,
Undisplacement.
distance time.
Oh, okay,
To be
let's
better. Yes. What's the difference? Displacement is always the distance to this reference point. Remember, if I have a free throw up, vertical throw, the displacement bigger, 2 meter, 3 meter, 4 meter, 5 meter, 6 meter, 10 meter, for instance. But then, as it reaches the maximum point, what does this chalk do? Will be attracted again by the earth, going downward. And now, is it still 10 meter? No, 9 meter maybe. What about now? 8, 7, 6, 5, 4, 3, 2, 1, and 0. Does it say the same like what I just demonstrated? The first picture say the same, correct?
Yes.
But be careful. I sweat this out through the time, meaning it's not like, but rather the process is looking like this, correct? Become more, reaching maximum point, and then getting decreases again. If you see this picture, that reminds you of one mathematical curve. What is it?
Which one?
This one reminds you of one typical curve that you do. Yes, ma'am. Parabola, or in German, parabel. That's right. Cool. And what about this now? I make a claim that this distance time graph, the same actually like the one before, explaining the same thing. Can you believe me?
Yeah.
And VFAD, how do you agree with me? Can you explain? Agree that this one actually describes the same very thing like the displacement time graph, which is this vertical throw. Yes, Shihab.
Distance is not relative to the starting point, so
Yes.
it always keeps on going up. And
Yes.
this is just the exact same shape. If like the second half of it was flipped around,
Yes. Reflected to the vertical line or the horizontal line, then actually yes. So basically, it always increases, no matter how the direction is, right? Even though it's going in the negative directions, I don't care, because 10 meter, then now not 7, not 5, 6, not 5, 4, 3, 2, 1, but rather 10 meter and then 11 meter. That's the distance traveled by this chalk, yeah? Despite of the directions. Understand everyone? Yes. It's okay. Can I review that again through a simple exercise that we did last time? This is the reference point, Kathleen. If I go there, 10 meter, how big is my displacement? 10 meter. Why? Because I have been displaced from the starting point to this point, I've been displaced 10 meters away. Now I'm 10 meters from the starting point, correct? How far is my distance? I have traveled 10 meters, the same thing. Now, nothing happens, nothing changed, both in displacement and distance, identical. But once I say, okay, I go back 6 meters to the left, now everything changes. When it comes to distance, you still remember? How big is my distance traveling? 16, because you travel exactly the troop length the weight you take, right? 10 meters plus 6. That's distance or displacement? Distance. What about displacement? You still remember? It's just the shortest distance or the shortest length between the end point and the starting point. Where's the end point? Here. Where's the starting point? There. How far is it now? Correct? Which is now displacement? 4 meters. You understand? Yes, ma'am. Yes, sir. Sorry, yes, sir.
Is there a letter for displacement?
I usually use only S to denote the distance, and since displacement is just this to the reference point, I do it as a factorial S. Yes, ma'am. Yeah. Let's take it some value so that you can understand. Now, I'm going to now flip this horizontal situations that I have, flip it 90 degrees up. Now, it's the starting point, am I right? Now as the time goes, since I throw it out, after 1 second, it takes this distance. Is it the distance? Yes. But is it also displacement? Yes, because that's the length between the starting point and the end point, correct? Now, what about after 2 seconds? Let's say this is 10 meters. Distance? 10 meters. Displacement? 10 meters. How far have you been? How far has the chalk been displaced from the starting ground to this point? The same, right? Now, but then, as the gravity forces this chalk to go downward again, it has reached the maximum, for instance. Now, after 3 seconds, for instance, this one is, let's say, the number 8. The scale here says, hey, this is the 8. Now, how far is the displacement? 8 meters. Meaning, how far are you from the starting point, hey, brother chalk? Hey, the brother chalk is now in 8 meter distance from the starting point. Yes? The brother chalk is now there, has been displaced 8 meters only from the starting point. But he might complain to you, no way, La, I am the chalk. I have been traveled actually 12 meters distance. Because I have gone up and go down again. Actually, I have been tiredly, I don't know, tiresomely, anything word, 12 meters. Do you understand now? Therefore, if you see the picture below, here, Sister Kathleen, after 10 meters, the next second, he actually here, 12 meters for instance, not the 8 meter displacement. You have to really understand the difference between displacement, how far have you been displaced, with the distance. Understand? The same very thing, describe the same thing, but depict it into two different things. Now, is it clear so far, everyone? Okay, this is the displacement time graph and the distance time graph. Now, what about the velocity? Not speed, yeah? Velocity. Do you still remember velocity concerns about the directions, correct? If I have motions going up, then the velocity will be positive. If it's negative, meaning the directions is downward. So let's say I throw it up. I throw, then this chalk has an initial velocity, correct? Therefore they call it U. I call it VI last time. Am I right? Not U, but VI. Why is it positive? Why it has positive value? Let's say 20 meters per second. Why?
Because the initial throw is going up in a positive direction while having the most strength.
Yes. So that's why the velocity is not positive. But can you guess why is it getting smaller, 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 smaller? Adam?
Because gravity will try to pull it down.
Yes. The gravity try to slow it down. What do you call again? The process of slowing down? Retardation, you know the we don't like that word, yeah. I usually use not the retardations because it's a simple word, yeah. How do you call it? Retardations, yes, fine, thank you. Deceleration. That's right. It's decelerated, correct?
Yeah.
And can you guess where it is? As the velocity reaches zero, meaning stop, for a small time of point of time. Get it?
When it reaches the peak.
The peak, the maximum. All right. What about here, Kathleen? Can you describe what happens here?
It starts
Accelerated in negative directions. Do you still remember decelerations last time? That this one is not deceleration, even though the A is negative too. But this is the accelerations in the negative directions. Understand? Getting bigger, 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 bigger with the velocity. Now, why they shade the area? You know the word shade, right? In German we call it arsieren. Wir haben das arsieren. Nein, no, not the correct word. What is the correct word for to shade an area? Schraffieren. Schraffieren.
nicht so einfach.
Shaded area, shaded area is called schraffierte. Shaded, schraffieren, schraffierte Fläche. Hm?
So eingefärbte.
Wenn das eine andere Farbe, ja, eingefärbt. But here is schraffieren, shaded. Yeah, shaded. The shaded area is the schraffierte Fläche. What does it mean, the shaded area? Last time. Shaded.
Distance traveled.
Distance traveled. Very good. Remember that? This is the distance traveled. Identical, symmetrical.
Sorry?
Are the two areas symmetrical? Yes. Meaning the distance you travel up, the same distance you travel down. Understand? Alright. Okay. Now I'm going to read one thing here. The displacement of the object. Can you read together with me, Brother Gary?
What was it? The displacement of the object?
Yeah, starting from this sentence. Brother.
The displacement of the object changes with time, as shown by figure 1. The line in this graph fits the equation distance equals as velocity times time minus half of
G, gravitational acceleration.
acceleration, where distance is the displacement, t is the time taken, and u is the initial velocity of the object.
Yes. Since you are not allowed to mark the book, yeah, then can you copy the formula? You are not allowed to
Can we
mark
mark-
the
can we
book.
mark
Can you
it?
copy the formula there first?
What do we mark it in our?
Oh, you work on the
Yes.
then you can mark.
Oh,
Yeah, you can just
Yes,
mark it
if you
here.
want to. Yes,
Oh.
you may change. It's okay, Sheila.
I
It's
didn't
okay.
realize we were allowed
Copy
to
it, copy it. It's okay. Copy
Too
it.
late now, already.
Too late now. Yes.
L.
Which one?
The formula there, the one
The
that
one
Brother
is-
Gary has read.
Wow, finally.
I know, I try.
The displacement is u times t. What is u again? Initial velocity times t or times delta t. I usually use delta t. Times the time taken plus or minus?
It's minus.
Okay, by you use minus. I actually don't like minus, but it's okay. Just use it.
But now we feel bad about using it.
Since I said so, yeah. You don't have to understand this notation, but one day if you are studying Ellen in university, it's probably the most frequently written formulae by your professor because it's factorial. Yes, sir.
Is A gravity?
Yes, correct. This A is the gravitational accelerations, but since I just write it in this formula, only the magnitude, not the vector, and I know that the directions is downward, that's why this A is negative G, and this negative is put in front of the 1/2. You understand now? Yes. Times t squared or delta t squared, and this one is therefore u times t, but I omit all the vectors and just write this is the magnitude of my displacement.
Wouldn't that make the answer completely different though?
Half different, but not completely different. Half different, yes, I know. I avoid speaking about vectors because I know that you haven't learned maths about
Yeah.
this. That's why I don't want to burden you with this factorial. Just use this, totally fine. Okay? Now, the gradient of the lines represent the velocity of the object. You know that the gradient of the tangent especially, right, represent the velocity of the object. Now, can I just do this? But before I do this, I have something for you first. Yes.
Can I go to the bathroom?
No.
Oh, you stopped hiccuping.
Huh?
Time to
Let
activate
a
it
big
again.
hiccup out in the bathroom.
This select the verb or the vertical throw is quite similar with the exercise that I'm going to do now with you. Yes.
Can we go to the bathroom?
Yes. But this exercise now called free fall, freie Fall in German, because this only taken the second half. Now this process going up, but from a certain height it's been released. Diese, wie nennt man das in German? Top? Kreide, die Kreide, der Kreide, die Kreide, die Kreide wird dann losgelassen. Stimmt's?
Yeah.
Okay, good. That's exactly what I want to do now before I go to a new topic. I want to distribute to you. This is by the way from the second ebook, so
Oh,
If-
please go on that.
yes, can you keep it for Brother Arjuna?
And everything I'll throw it at
What page is it?
You like my son, you love airplanes. From papers. But it's a good starting to understand aerodynamics so that you can explain to Sister Kathleen.
I love aerodynamics.
I love too. But you don't have to understand aerodynamics if you want to go flying with an airplane, right?
No, I want to go flying with a car.
We have to go now. We have to go back to
I love flying. I don't understand how much joy I get.
Can I take a photo of this?
Sure.
Right now?
Sure.
Now?
Yeah.
This second?
I'm scared like I may lose it and then like you just won't get it.
Damn, bro.
Are we supposed to just read this?
We want to do the exercise as an example I have taken that from page 28, brothers and sisters, from page 18.
Women in STEM.
Yeah, the most beautiful girl here in this world. Yeah, very lucky. Page
You want me to
28.
turn that time for 2 years ago?
Yeah.
Page 28. Page 28. Are you with me, everyone? Page 28.
Yes.
Not there, Chad. In the ebook.
Ebook
Oh.
It's not
In the
there.
Cambridge book.
and the first
You're
ebook and
holding
the
it.
second ebook.
Or on the paper that you have.
That's why I printed for you because you don't have the
Sure.
book print out. Yeah. A steel ball. Who wants to read? Ali. Can you? Questions number 18 from these extra hands.
A steel ball falls from the west through a height of 2.10 meters.
So the height means all the way through this distance height, right? 2.10 meter. Okay. An electronic time records a time of 0.67 second for the ball. Meaning, what is the time taken from here to here? 0.67. Alright. Now calculate the average accelerations of the ball as it falls. B. Suggest reasons why the answer is not exactly 9.8. Can you try first without my help? And maybe there's formula that you just added just now can help you there. Maybe.
Can you take my binder?
Hmm?
Can you
Can you?
take my binder?
Yes. Why? You is more comfortable for it to bind there.
No, my binder.
Oh, binder. I thought your hairband. Sorry. Yes, you may. Yeah. Your ordinary.
Yeah, yeah.
Oh, you call it binder, yeah, in English, yeah.